Faraday's second law of electrolysis. Faraday's second law of electrolysis. This is today's lesson. Let us see the matter in detail. Faraday's second law of electrolysis. This is according to Faraday's second law of electrolysis. Here, amount of substance dissolved from the anode or deposited at the cathode is directly proportional to the chemical equivalent of the elements when electricity passed through it is constant. So, amount of substance dissolved from the anode or deposited at the cathode is directly proportional to the chemical equivalent of the element when electricity passed through it is constant. Here, this is chemical equivalent. Now, let us see what chemical equivalent is. Suppose chemical equivalent of silver in silver nitrate. Chemical equivalent of silver in silver nitrate. Atomic mass of silver 107.868. Atomic mass of silver divided by valency of silver in its compound. Here, valency of silver is 1. So, chemical equivalent of silver in silver nitrate is this. Similarly, chemical equivalent of copper, suppose in cupric nitrate. Chemical equivalent of copper in cupric nitrate. Atomic mass of copper is 63.5 and here valency of copper is 1. In the compound cuprous nitrate, valency of copper is 1. So here chemical equivalent of copper in cuprous nitrate is 63.5. Again, chemical equivalent of copper in cupric nitrate. Atomic mass of copper divided by valency of copper in its compound. Here, valency of copper in the cupric nitrate is 2. So, chemical equivalent of copper will be here 31.75. Again, chemical equivalent of chromium in chromic sulfate. Atomic mass of chromium 52. Here, valency of chromium is 3. It will be 17.33. So, chemical equivalent of chromium in chromic sulfate is 17.33. Copper in cuprous nitrate is 63.5. In cupric nitrate, this is 31.75. And chemical equivalent of silver in silver nitrate is 107.868. That is chemical equivalent, which is denoted by E. Here, silver first, then copper, and then chromium. According to Faraday's second law of electrolysis, the amount of substance dissolved from the anode or deposited at the cathode will be directly proportional to the chemical equivalent of the elements when amount of current passed through it is same. That is, amount of substance dissolved from the anode or deposited at the cathode will be higher for silver, then copper, and after that chromium. Now let us try to prove the matter. Let us consider this is electrolytic cell in which electrolytic solution of silver nitrate has been taken. Silver plus, nitrate minus. Anode, cathode. External source of electricity. Here suppose a meter which is used to measure the current. Another cell. This is cell 1. This is cell 2 in which electrolytic solution of copper sulfate has been taken. Anode, cathode. Ammeter, cell 3 in which electrolytic solution of chromic sulfate has been taken. Anode, cathode. Here current passed through it is Q. Suppose same amount of current, then let us try to prove that amount of substance dissolved from the anode or deposited at the cathode will be directly proportional to the chemical equivalent of these elements when amount of current passed through it is constant. For the silver nitrate, the chemical reaction occurs here. Silver plus receives electron to form solid silver. Here 1 mole electrons, charge of 1 mole electrons is 96,500 coulomb, and gram atomic mass of silver is 107.868 gram. Gram atomic mass of silver. It means 96,500 coulomb electricity deposits 96,500 coulomb electricity deposit this gram of silver. Then 1 coulomb electricity deposit divided by 96,500 coulomb. This is equal to 0.001118 gram per coulomb. It means here for passing 1 coulomb electricity, amount of silver deposited is this, which is electrochemical equivalent as well. This is electrochemical equivalent of silver as well. Now for cell 2, the chemical reaction occurs here. Copper 2 plus ion receives electrons. Here, reception of electron to form solid copper. 2 moles of electrons. Charge of 2 moles electrons is this. And gram atomic mass of copper. Now, this Coulomb electricity deposit 63.5 gram of copper. Then 1 Coulomb electricity deposit 63.5 gram divided by 96,500 Coulomb. This is equal to 0.00033 gram per Coulomb. Here, for passing 1 Coulomb electricity, amount of copper deposited on the surface of the cathode is this, which is less than silver. Again, for chromium 3 plus ion receives electrons to form solid chromium. 3 moles of electrons. Charge this Coulomb. Gram atomic mass of chromium approximately 52 gram. Here 3 times 96,500 Coulomb electricity deposit this gram of chromium. Here this gram of silver. In case of chromic sulfate, for passing 1 Coulomb electricity, chromium deposited here is 52 divided by 3 times this. This is equal to 0.00018 gram per Coulomb. That is, for passing 1 Coulomb electricity, chromium deposited on the surface of the cathode is this gram, which is less than copper. That is, amount of silver deposited is higher than copper and then chromium. And we know chemical equivalent of silver is higher than copper, and after that chromium. That is, amount of substance deposited at the cathode or dissolved from the anode is directly proportional to the chemical equivalent of the elements, which is Faraday's second law of electrolysis after English chemist Michael Faraday. Thank you for watching.